Elements of groups 16, 17 and 18. Exercise pages 163 to 164. Exercise Q1.01, page 163. Select appropriate answers for the following. Which of the following has highest electron gain enthalpy? 1. Fluorine. 2. Chlorine. 3. Bromine. 4. Iodine. Solution. Chlorine. Exercise Q1.02, page 163. Select appropriate answers for the following. Hydrides of group 16 are weakly acidic. The correct order of acidity is underscore. 1. H2O greater than H2S greater than H2Se greater than H2Te. 2. H2Te greater than H2O greater than H2S greater than H2Se. 3. H2Te greater than H2Se greater than H2S greater than H2O. 4. H2Te greater than H2Se greater than H2O greater than H2S. Solution. Hydrides of group 16 are weakly acidic. The correct order of acidity is H2Te greater than H2Se greater than H2S greater than H2O. Exercise Q1.03, page 163. Select appropriate answers for the following. Which of the following element does not show an oxidation state of +4? 1. O. 2. S. 3. Se. 4. Te. Solution. O. Exercise Q1.04, page 163. Select appropriate answers for the following. High acid when heated with conc. H2SO4 forms underscore. 1. HiO3. 2. KiO3. 3. I2. 4. Ki. Solution. High acid when heated with conc. H2SO4 forms I2. Exercise Q1.05, page 163. Select appropriate answers for the following. Ozone layer is depleted by underscore. 1. NO. 2. NO2. 3. NO3. 4. N2O5. Solution. Ozone layer is depleted by NO. Exercise Q1.06, page 163. Select appropriate answers for the following. Which of the following occurs in a liquid state at room temperature? 1. HiO3. 2. HBr. 3. HCl. 4. HF. Solution. HF. Exercise Q1.07, page 163. Select appropriate answers for the following. In pyrosulfuric acid, oxidation state of sulfur is underscore. 1. Only +2. 2. Only +4. 3. +2 and +6. 4. Only +6. Solution. In pyrosulfuric acid, oxidation state of sulfur is only +6. Exercise Q1.08, page 163. Select appropriate answers for the following. Stability of interhalogen compounds follows the order underscore. 1. BRF greater than IBr greater than ICl greater than CLF greater than BRCl. 2. IBr greater than BEF greater than ICl greater than CLF greater than BRCl. 3. CLF greater than ICl greater than IBr greater than BRCl greater than BRF. 4. ICl greater than CLF greater than BRCl greater than IBr greater than BRF. Solution. Stability of interhalogen compounds follows the order CLF greater than ICl greater than IBr greater than BRCl greater than BRF. Exercise Q1.09, page 163. Select appropriate answers for the following. BRCl reacts with water to form underscore. 1. HBr. 2. Bridge 2 plus Cl2. 3. HOBr. 4. HOBr plus HCl. Solution. BRCl reacts with water to form HOBr plus HCl. Exercise Q1.1, page 163. Select appropriate answers for the following. Chlorine reacts with excess of fluorine to form underscore. 1. CIF. 2. CIF3. 3. CIF2. 4. Cl2F3. Solution. Chlorine reacts with excess of fluorine to form CIF3. Exercise Q1.11, page 163. Select appropriate answers for the following. In interhalogen compounds, which of the following halogens is never the central atom? 1. I. 2. Cl. 3. Bridge. 4. F. Solution. F. Exercise Q1.12, page 163. Select appropriate answers for the following. Which of the following has one lone pair of electrons? 1. IF3. 2. ICl. 3. IF5. 4. ClF3. Solution. IF5. Exercise Q1.13, page 163. Select appropriate answers for the following. In which of the following pairs, molecules are paired with their correct shapes? 1. I3 bent. 2. BRF5. Trigonal bipyramidal. 3. ClF3. Trigonal planar. 4. BRF4. Square planar. Solution. BRF4. Square planar. Exercise Q1.14, page 163. Select appropriate answers for the following. Among the known interhalogen compounds, the maximum number of atoms is underscore 1, 3, 2, 6, 3, 7, 4, 8. Solution. Among the known interhalogen compounds, the maximum number of atoms is 8. Exercise Q2.01, page 163. Answer the following. Write the order of the thermal stability of the hydrides of group 16 elements. Solution. The decreasing order of thermal stability. H2O greater than H2S greater than H2Se greater than H2Te. Exercise Q2.02, page 163. Answer the following. What is the oxidation state of Te in TeO3? Solution. Oxidation number of Te plus oxidation number of O equals 0. Oxidation number of Te plus 3 times 2 equals 0. Oxidation number of Te 6 equals 0. Hence, oxidation number of Te in TeO3 equals plus 6. Exercise Q2.03, page 163. Answer the following. Name 2 gases which deplete ozone layer. Solution. 2 gases that deplete ozone layer. Nitric oxide, no chlorofluorocarbons, freons. Exercise Q2.04, page 163. Answer the following. Give 2 uses of ClO2. Solution. 1. ClO2 is used as a bleaching agent for paper pulp and textiles. 2. It is also used in the water treatment. Exercise Q2.05, page 163. Answer the following. What is the action of bromine on magnesium metal? Solution. Bromine reacts with magnesium to form magnesium bromide. Exercise Q2.06, page 163. Answer the following. Write the names of allotropic forms of selenium. Solution. Allotropes of selenium. Red and gray selenium. Exercise Q2.07, page 163. Answer the following. What is the oxidation state of S in H2SO4? Solution. Oxidation number of H plus, oxidation number of S plus, oxidation number of O equals 0. 2 times plus 1 plus oxidation number of S plus 4 times 2 equals 0. Oxidation number of S plus 2 to 8 equals 0. Hence, oxidation number of S in H2SO4 equals plus 6. Exercise Q2.08, page 163. Answer the following. The pKa value of HCl is 7.0 and that of Hi is minus 10.0. Which is the stronger acid? Solution. Smaller is the pKa value, greater is its acidity. Hence, Hi is stronger acid than HCl. Exercise Q2.09, page 163. Answer the following. Give one example showing reducing property of ozone. Solution. Reaction showing reducing property of ozone is exercise Q2.1, page 164. Answer the following. Write the reaction of conc. H2SO4 with sugar. Solution. Exercise Q2.11, page 164. Write any two uses of chlorine. Solution. Uses of chlorine. 1. Large quantities of chlorine are used industrially for bleaching wood pulp required for the manufacture of paper and rayon, bleaching cotton and textiles. 2. It is used in the extraction of gold and platinum. 3. It is used for the manufacture of dyes, drugs and organic compounds such as CCl4, CHCl3, refrigerants, etc. 4. It is used in sterilizing drinking water. 5. It is used in preparation of poisonous gases such as phosgene, COCl2, tear gas, CCl3 number 2, mustard gas, Cl, C2H4S, C2H4Cl. 6. It is used in the manufacture of DDT and BHC, which are important insecticide. 7. It is used in the manufacture of vinyl chloride, which is starting material for polyvinyl chloride plastics. 8. It is used in the manufacture of bleaching powder, aluminium chloride, hydrogen chloride, hypochlorites, chlorates, perchlorates, etc., which are important industrial compounds. Exercise Q2.12, page 164. Complete the following. ICl3 plus H2O, right pointing arrow underscore plus ICL. Solution. ICl3 plus H2O, right pointing arrow HiO3 plus 5HCl plus ICL. Exercise Q2.12, page 164. Complete the following. L2 plus KClO3, right pointing arrow underscore plus KiO3. Solution. L2 plus KClO3, right pointing arrow ICl plus KiO3. Exercise Q2.12, page 164. Complete the following. BrCl plus H2O, right pointing arrow underscore plus HCl. Solution. BrCl plus H2O, right pointing arrow HOBr plus HCl. Exercise Q2.12, page 164. Complete the following. Cl2 plus ClF3, right pointing arrow underscore. Solution. Cl2 plus ClF3, right pointing arrow 3ClF. Exercise Q2.12, page 164. Complete the following. H2C equals CH2 plus ICl, right pointing arrow underscore. Solution. H2C equals CH2 plus ICl, right pointing arrow I, CH2CH2Cl. Exercise Q2.12, page 164. Complete the following. 2ZOF4 plus CO2, right pointing arrow underscore plus CF4. Solution. 2ZOF4 plus CO2, right pointing arrow 2XEO2F2 plus CF4. Exercise Q2.12, page 164. Complete the following. XEF6 plus H2O, right pointing arrow underscore plus 2HF. Solution. XEF6 plus H2O, right pointing arrow ZOF4 plus 2HF. Exercise Q2.12, page 164. Complete the following. ZOF4 plus H2O, right pointing arrow underscore plus HF. Solution. ZOF4 plus H2O, right pointing arrow XEO2F2 plus HF. Exercise Q2.13, page 164. Match the following. A. BZOF2. Xenon trioxidifluoride. XEO2F2. Xenon monoxidifluoride. XEO3F2. Xenon dioxytetrafluoride. XEO2F4. Xenon dioxidifluoride. Solution. A. BZOF2. Xenon monoxidifluoride XEO2F2. Xenon dioxidifluoride XEO3F2. Xenon trioxydifluoride XeO2F4. Xenon dioxytetrafluoride. Exercise Q2.14, page 164. What is the oxidation state of xenon in the following compounds? ZOF4, XeO3, XeF6, XeF4, XeF2. Solution. Compound. Oxidation state of xenon. ZOF4 plus 6 XeO3 plus 6 XeF6 plus 6 XeF4 plus 4 XeF2 plus 2. Exercise Q3.01, page 164. Answer the following. The first ionization enthalpies of S, Cl, and Ar are 1000, 1256 and 1520 kJ per mole -1. Respectively. Explain the observed trend. Solution. 1. The elements S, Cl, and Ar belong to third period of the periodic table. 2. Across a period, effective nuclear charge increases and atomic size decreases with increase in atomic number. Therefore, the energy required for the removal of an electron from the valence shell, i.e., increases in the order S less than Cl less than Ar. Exercise Q3.02, page 164. Answer the following. Acidic character of hydrides of group 16 elements increases from H2O to H2Te. Explain. Solution. The acidic character of the hydrides increases from H2O to H2Te because the bond dissociation enthalpy of the He bond decreases down the group, where E equals O, S, say. Te. Exercise Q3.03, page 164. Answer the following. How is dioxygen prepared in the laboratory from KClO3? Solution. Dioxygen is prepared by heating potassium chlorate KClO3 in presence of the catalyst MnO2. Exercise Q3.04, page 164. Answer the following. What happens when lead sulfide reacts with ozone O3? Solution. Ozone oxidizes lead sulfide to lead sulfate. Exercise Q3.04, page 164. Answer the following. What happens when nitric oxide reacts with ozone? Solution. Exercise Q3.05, page 164. Answer the following. Give two reactions showing the oxidizing property of concentrated H2SO4. Solution. Metals and nonmetals both are oxidized by hot, concentrated sulfuric acid which itself gets reduced to SO2. Exercise Q3.06, page 164. Answer the following. Discuss the structure of sulfur dioxide. Solution. 1. Sulfur dioxide is angular with O, O bond angle of 119.5 degrees. 2. The O double bond arises from d-pi-p-pi bonding. 3. It is a resonance hybrid of two canonical forms as shown below. Exercise Q3.07, page 164. Answer the following. Fluorine shows only -1 oxidation state while other halogens show -1, +1, +3, +5 and +7 oxidation states. Explain. Solution. 1. The fluorine atom has no d orbitals in its valence shell and therefore cannot expand its octet. Thus, fluorine is the most electronegative exhibit -1 oxidation state only. 2. Cl, bridge, and I exhibit -1, +1, +3, +5, and +7 oxidation states. This is because they are less electronegative than F and possess empty d orbitals in the valence shell and therefore can expand the octet. Exercise Q3.08, page 164. Answer the following. What is the action of chlorine on excess NH3? Solution. Chlorine when reacted with excess of ammonia gives ammonium chloride and nitrogen. Exercise Q3.08, page 164. Answer the following. What is the action of chlorine on Fe? Solution. Chlorine reacts with Fe to form ferric chloride. Exercise Q3.09, page 164. Answer the following. How is hydrogen chloride prepared from sodium chloride? Solution. 1. In the laboratory, hydrogen chloride is prepared by heating sodium chloride common salt with concentrated sulfuric acid. 2. HCl gas can be dried by passing it through concentrated sulfuric acid. Exercise Q3.1, page 164. Answer the following. Draw structures of XEF6. Solution. Structures of XEF6. Exercise Q3.1, page 164. Answer the following. Draw structures of XEF3. Solution. Structures of XEF3. Exercise Q3.1, page 164. Answer the following. Draw structures of ZOF4. Solution. Structures of ZOF4. Exercise Q3.1, page 164. Answer the following. Draw structures of ZOF2. Solution. Structures of ZOF2. Exercise Q3.11, page 164. Answer the following. What are interhalogen compounds? Give 2 examples. Solution. An interhalogen compound is a compound formed by a combination of atoms of different halogens. E.g., ClF, BrF3. Exercise Q3.12, page 164. Answer the following. What is the action of hydrochloric acid on NH3? Solution. Hydrochloric acid reacts with ammonia and gives white fumes of ammonium chloride. Exercise Q3.12, page 164. Answer the following. What is the action of hydrochloric acid on Na2CO3? Solution. Hydrochloric acid reacts with sodium carbonate to give sodium chloride with the release of CO2 gas. Exercise Q3.13, page 164. Answer the following. Give 2 uses of HCl. Solution. 1. It is used in the manufacture of chlorine and chlorides such as ammonium chloride. 2. It is used in the preparation of aqua regia, which is used to dissolve noble metals like gold. Exercise Q3.14, page 164. Answer the following. Write the names and structural formulae of oxoacids of chlorine. Solution. 1. Hypochlorous acid, HOCl. 2. Chlorous acid, HOClO or HClO2. 3. Chloric acid, HClO3. 4. Perchloric acid, HClO4. Exercise Q3.15, page 164. Answer the following. What happens when Cl2 reacts with F2 in equal volume at 437 K? Solution. When Cl2 reacts with F2 in equal volume at 437 K, chlorine monofluoride is formed. Exercise Q3.15, page 164. Answer the following. What happens when bridge 2 reacts with excess of F2? Solution. When bridge 2 reacts with excess of F2, bromine trifluoride is formed. Exercise Q3.16, page 164. Answer the following. How are xenon fluorides XEF2, XEF4 and XEF6 obtained? Give suitable reactions. Solution. Xenon fluorides are generally prepared by direct reaction of xenon and fluorine in different ratios and conditions, such as temperature, electric discharge and photochemical reaction. Exercise Q3.17, page 164. Answer the following. How are XEF2 and ZOF4 prepared? Solution. 1. Preparation of XeO3. Fluorides of xenon react with water to form XeO3. Exercise Q3.18, page 164. Answer the following. List the uses of neon and argon gases. Solution 1. Uses of neon gas. I. It is mixed with helium to protect electrical equipments from high voltage. E. It is filled in discharge tubes with characteristic colors. E. It is used in beacon lights. Uses of argon gas. Argon along with nitrogen is used in gas-filled electric lamps. This is because Ar is more inert than N. It is usually used to provide an inert temperature in a high metallurgical process. It is also used in laboratories to handle air-sensitive substances. Solution 2. Uses of neon. Neon is used in discharge tubes and fluorescent bulbs for advertisement display purposes. Glow of different colors. Neon signs can be produced by mixing neon with other gases. Neon bulbs are used in botanical gardens and in greenhouses. Uses of argon. Argon is used mainly to provide an inert atmosphere in high-temperature metallurgical processes such as arc welding of metals and alloys. In the laboratory, it is used for handling substances which are air-sensitive. It is used in filling incandescent and fluorescent lamps where its presence retards the sublimation of the filament and thus increases the life of the lamp. It is also used in neon signs for obtaining lights of different colors. Exercise Q 3.19, page 164. Answer the following. Describe the structure of the ozone. Give 2 uses of ozone. Solution. Structure of ozone. Ozone O3 is an angular molecule. The 2 O bond lengths in the ozone molecule are identical, 128 pm, and the O bond angle of about 117 degrees. It is a resonance hybrid of 2 canonical forms. Exercise Q 3.2, page 164. Answer the following. Explain the trend in following atomic properties of group 16 elements. Atomic radii. Solution. Atomic radii. The atomic radii increase down the group, as a result of an increase in the number of quantum shells. Exercise Q 3.2, page 164. Answer the following. Explain the trend in following atomic properties of group 16 elements. Ionization enthalpy. Solution. Ionization enthalpy. The ionization enthalpy decreases down the group due to an increase in the atomic size. Group 16 elements have less ionization energy than the corresponding group 15 elements. Exercise Q 3.2, page 164. Answer the following. Explain the trend in following atomic properties of group 16 elements. Electronegativity. Solution. Electronegativity. The electronegativity decreases down the group. Oxygen has the highest electronegativity next to fluorine amongst all the elements. Exercise Q 4.1, page 164. Answer the following. Distinguish between rhombic sulfur and monoclinic sulfur. Solution. The following are the points of difference between rhombic alpha sulfur and monoclinic beta sulfur. Rhombic sulfur alpha sulfur. Monoclinic sulfur beta sulfur 1. It is a pale yellow colored solid. 1. It is bright yellow solid 2. It forms orthorhombic crystals. 2. It forms needle-shaped monoclinic crystals 3. Its melting point is 385.8 K. 3. Its melting point is 393 K. 4. Its density is 2.06 grams per cc. 4. Its density is 1.98 grams per cc. 5. It is insoluble in water and soluble in CS2. 5. Soluble in CS2. 6. It is stable below 369 K and transforms to beta sulfur above this temperature. 6. It is stable above 369 K and transforms into alpha sulfur below this temperature. 7. It is prepared by the evaporation of Rolls sulfur in CS2. 7. It is prepared from rhombic sulfur. Exercise Q 4.2, page 164. Answer the following. Give 2 reactions showing the oxidizing property of concentrated H2SO4. Solution. Metals and nonmetals both are oxidized by hot, concentrated sulfuric acid which itself gets reduced to SO2. Exercise Q 4.3, page 164. Answer the following. How is SO2 prepared in the laboratory from sodium sulfite? Solution. In laboratory, sulfur dioxide is prepared by treating sodium sulfite with dilute sulfuric acid. Exercise Q 4.4, page 164. Answer the following. Describe the manufacturing of H2SO4 by the contact process. Solution. Sulfuric acid is manufactured by the contact process, which involves the following 3 steps. 1. Roasting in air. Sulfur or sulfide or iron pyrites, on burning or roasting in air, produces sulfur dioxide. 2. Catalytic oxidation of sulfur dioxide. Sulfur dioxide is oxidized catalytically with oxygen to sulfur trioxide, in the presence of B2O5 catalyst. The reaction is exothermic and reversible, and the forward reaction leads to decrease in volume. Therefore, low temperature, 720 K, and high pressure, 2 bars, are favorable conditions for maximum yield of SO3. 3. Absorption, followed by dilution of sulfur trioxide gas. Sulfur trioxide gas, from the catalytic converter, is absorbed in concentrated H2SO4 to produce oleum. The sulfuric acid obtained by contact process is 96 to 98% pure.